Hello guys, welcome back. In this video, let us understood how to select a ML model. If you have multiple ML models based on your data, based on the input and output data, you predicted multiple models may fit or multiple ML models may be suitable for your requirement, but you don't know which model is best. Then based on accuracy, we need to filter out which model is best. Now in this video, we will understood how to do this filtering or how to find the accuracy of any particular model, any ML model, and how to filter out other models. In this video, we will take a reference of three models like random forest classification model and SVC, support vector classification model, and Gaussian naive Bayes model also we will take. And we will use it for image related data. We will use it for some specific task. Like we will take some input data like 8 by 8 images data, and we will train our models, these three models, and we will categorize them based on 10 different classes. Those all data related to 10 different classes, and we will find the accuracy with 20% of that data. Now, so let's implement this so that it will be very clear to you. Now, I'm again specifying what are the tasks that we're gonna do in this demo. The first one, we will need to load some training data. Currently, for this demo, for this lab, I'm using images, 8 by 8 images, and I'm loading that data, and I'm classifying. I'm expecting to classify those images based on 10 different classes. So I'll also provide image as well as that particular image related labels. As a features, I'll provide that data, and as a labels, I'll provide those 10 different classifications 0 to 9. And then, so next what I need to do, after loading my data, I need to prepare my data for training as well as the testing. That is, I need to split my data. 20% I want to use for testing and 80% I want to use for training. So like that, in the similar fashion, I'll try to split my data set. Then after, what we need to do, we just need to pick whatever the models that we have, then we need to train the models as well as test the models, and at last we need to print the accuracy. Then based on the accuracy result that was printed, we will pick what are the best fit for our requirement that we can able to classify based on that accuracy. So those are the tasks that we need to do. The first task, that is, we need to, so first what we need to load some training data. For this, I want to take the data set that is already available from sklearn library. I have multiple data sets already available. So for this demo, I'm just importing load digits. So you can see multiple data sets I have: iris data set, I have digits, I have diabetes data set, wines data set files. You can see multiple data sets are visible to me. Now from this, I'm just taking this digits data set, where this digits data set actually contains two things, that is images as well as 8 by 8 images, 8 by 8 size images, dimension images, and different classes. Like output will be like, it will classify each image into any one of the 10 categories. Now let's load that data. Let's take the input data and let's load that data. So first I want to take the data, so I'm just loading the digits. Load digits. So this will load our data. Then you can even print the data whatever you have, so that we can able to clearly see what or how the data set will really look like. Yes, you can able to observe this. You have the data will be like this. Yeah. So this is the file name that I have created, ML model underscore testing.py. So that's what I run. I have this data as well as, yeah, I have this data, right? I have this data, and yes, I have this data as well as this target and multiple things I have. So in this, whatever the data represents and whatever the target represents, this data is representing images, multiple images. Then what this target is representing? This target is actually representing classification of those images into multiple classes, 1 to 10, that is 0 to 9. The images will be classified up to 0 to 9. The data classifications are there. So among the classifications, the data will be classified. Now first I want to take the input features and I want to store it in X. So I have multiple features, so that's why I'm taking capital X. Now in this data, what I want data, in this data I want this data, so that's why I'm writing this. Okay, now we got the input and output. So where the output will be in this data, so in this target I have this output like data dot target I'm writing, so that from here I'll get the data, and that will be stored in this two variables. In this X I have that X related data, and in this Y I have target related data. Now I need to prepare my data set like input as well as output related to training and testing. That is, I want to split the data set, some amount of data set for training and some amount of data set for testing. So in order to do this training and testing data set splitting, we already have some library available in sklearn from sklearn dot model selection. So in this we have that train test split function. Now I'm using that train test split function. I'm passing my inputs like X represents the features, Y represents the output labels, and The splitting, I need to specify, right, how much amount of data is used for testing size. That I am specifying, like testing size will be 0.2, that is 20% of the data I need to use for testing, and the remaining 80% I need to use for training. So like that I specified by using this. Then how randomly you need to take it. So that random distribution we are specifying like 42. So now this function will split our data based on that. Then after splitting, I need to save this data in some variable. So that's why I'm taking the x train data to save the training data of x, and x test for storing the test data, y train related to training data saving, and y test related to testing related data saving. I'm using these variables. Okay, now we have taken, or we have loaded our data, and we even split our data into training as well as testing. Now the last thing, that is we need to incorporate, or we need to take our models, multiple models, then we need to identify, we need to train those models with our data, and we need to use that model, trained model, for predicting the response. So let's make it simple. What I want 3 models, right? Yes, I want 3 models. So I'm just taking the first one is random forest classifier model I want. So where that model is present, that model actually present in sklearn itself. So I'm taking that sklearn dot ensemble. You can see sklearn dot ensemble. I'm importing that random classifier, or random regressor, or embedding. So what you want? I want a classifier to classify my image among multiple, like those 10 classifications. I'm creating my models into this as a list. I'm storing my models into this models variable. So what are my models? One is this, that is this random forest classifier, and I want to use this with specific parameters, like what is the random state. I'm just taking the random state like 42. So this is one model I want to take, and the another model, that is a support vector classification, I want to take from support vector mechanism. So that also actually present in sklearn. Sklearn library provides you the required models that you want. So here you can see multiple data sets are available. Now in this SVM I'm importing. From that SVM I'm just importing the required thing, that is SVC, and I'm just taking this model into my models list. This is nothing but my ML model list, right? So this is nothing but my ML model list. So first I have taken this random forest classifier. Now I'm taking this SVC support vector classifier with some parameters, like how I want to classify, what is my kernel. Let's take a linear kernel. For this demo, since it's a classification based task, I'm just taking this linear kernel, and random state I want to take the same, that is 42. And apart of these two, I'm also expecting a Navi bias model. For this classification, I want to use a Navi bias model as well to compare. So that's why I'm importing that as well from this sklearn. So this sklearn is nothing but the library where the required models, the required ML models are actually present. What I want a Navi bias model. So that's why from sklearn.navi bias I'm importing Gaussian related Navi bias model I'm importing. So that I am saving into my model list. So that is here, Gaussian NB, in the form of a function I'm saving. Okay. So like this, we loaded our ML algorithm or ML models list, or ML algorithms, right? These all are nothing but ML algorithms. So these all are my ML algorithms list. Okay. Now I created whatever the algorithms or ML algorithms that I want to test with my data set. Now I want to take one by one ML algorithm, that is a one by one ML model, and I want to train that algorithm or train that model, and then test that model and find the accuracy. So for this, I'm using for loop for each model which is present in my ML algorithm list, nothing but in this. So I'm just copying, and for each model present in this list, I'm taking one by one model, and I'm training that model. I'm training each and every time my model, that is I'm feeding my model with the trained data set with these X input features and Y. So what is the training related output features? Y train. So that I have provided. Based on this data, I'm training my model. Now actually from this algorithm, after training, my model is obtained. So this is one more important question, that is what is the difference between your ML algorithm and your ML model? The only difference is ML algorithm is nothing but the algorithm that is that we are taking from sklearn library. And what is our ML model? After training our ML model or ML algorithm, after training our ML algorithm with our data set, we get actually required model. We get our actual model. Then so okay, our model got trained. Now what we want to do, we want to use this model, right? For what? For predicting. So I'm just writing the command predict. So now here I'm just providing the test data set so that it can able to predict that. Then okay, that predicted value I want to store it in a variable, like y predicted. Okay, now I have the predicted value as well. After my model got trained, I'm passing my test data set to my model to predict the outputs. Now my model is predicted and I got the output. So now I want to print my model, like what model I'm using, so that I'm printing. And so before this, I want to print something like a decoration to identify this is related to this model. Okay, so like this 80 times, let's say it will print, or okay, 30 times is enough. Okay, and so in between these things I want to print this. Okay, in between these I want to take a model. So this is the model, and after this model I want to specify the accuracy score of that model as well. I want to print the how much accurate that this model is. So that's why I'm printing this accuracy score as well. And I want to only up to three floating point values. I want to round off the output to 3 floating point values. So that's why I'm writing this dot 3f colon dot 3f, and dot format method I'm using. So in order to reflect my result, or reflect my accuracy result in this place in between these flower braces, I'm using this dot format method and finding the accuracy score. To find the accuracy score, we again need to import this accuracy score. So from where we need to import this accuracy score? You have, so in sklearn itself, so from sklearn library dot matrices. So your multiple matrices are there, you need to import that accuracy matrix from accuracy score matrix from here. Now I'm using that accuracy score matrix, and what I'm doing is I'm passing my y related test data as well as so actual test data. And what is the predicted value? Y related predicted value. We are passing whatever the predicted value that we are predicting, and what is the actual value, that is nothing but the test data. So that is this. Actual output is this, but the predicted output is this. Based on this, we are finding the accuracy score. So from where we imported this accuracy score? From this sklearn library, we imported this matrix from the sklearn.matrices. So not only this, we also have multiple matrices, like we have confusion matrix as well. So let's import it to see the response of it as well. Now I'm printing at the end like confusion matrix. So I'm just printing that as well, confusion matrix, and I'm passing the actual result like y test and the predicted value. So whatever the model that is predicted, that value. Okay, this will iteratively take one by one model, and the training will be happen internally by using this command. After that, we are predicting the response. Then we are just printing that model name, and we are printing the accuracy score, as well as we are printing the confusion matrix as well. Now I'm just rerunning this to see the result. Okay, so first our data will be loaded, like the features as well as the labels will be loaded. The features will be loaded into this, and the target represents the label. So I think we have written some spelling mistake. Okay, predict spelling. Okay, now let's rerun this. Okay, now we loaded our input features in the x variable, and we loaded our output in this y variable like labels, and then we taken these, or we just split our data set into two parts, like training as well as testing. Then we taken the required models into this list, and then we are taking one by one model and training that model, and we are predicting the output. Then we printing the model name as well as the accuracy of that model. Confusion matrix also we are printing. Now let's see the response. Yes, you can observe here the response related to the accuracy related to this model, that is this random forest model. If we observe, it performs decently, but might not match or might not provide as a high accuracy, like so 978 is the accuracy of another one. If we see the random forest related accuracy, that is 0.972, this is the confusion matrix of it, and the SVC accuracy 978, 0.978. That means more than this random forest accuracy. And okay, Gaussian heavy bias is the less accurate compared to this SVC as well as this random forest, only for this particular data set. So based on the data set that you are using, based on your requirement of training your model or using your model in particular use case, this may changes. For now, this Gaussian navy bias model is less accurate for our data set, whereas SVC is high accurate, and this is a bit less. Like SVC is likely achieves high accuracy because it handles structured data, like digits data set very well by separating the classes effectively. Whereas coming to this random forest, so it also performs well decently, but it does not match high accuracy like this SVC due to this random forest overfitting on pixel features. Whereas coming to this navy bias, it obviously performed a very low accuracy, that is up to 80%, 84.7%, 80 to 85, because of its dependence, like assumptions which did not suit for image data. So that's the reason why the classification or why the results will be like this. And so from this we can able to say that from these multiple models, for this task, for our particular task. For image classification between 10 classes based on the input images that we provide, this model is best suitable for us. So what is that model? That is this support vector classification model is best suitable for us for now. So after finding the accuracy, we specify that. Now let's also test these models related classification. Like let's take one more dataset, like iris dataset I want to take. So that is also one of the famous dataset where it contains 150 samples of flowers with only 4 features. So those inputs will be stored here. Like I want to load my iris right now. Now in that also the same, in this data, it have 4 features like sepal length and sepal width and petal length and petal width. So those 4 parameters related data will be taken and stored in this X variable, and based on those 4 features, the output will be classified into 3 classes. So either that 3 classes are stored in this target variable, that also we are taking and storing in this Y variable, and then so we are again doing the same thing. We are again passing the same parameters, and so let's check which model is working better. Sometimes some models will work better, whereas other models will not. So based on testing or classification related accuracy, you need to pick any one of the model. If every model is working well, then you can choose any one of the one. Now this navy bias is working well, the accuracy is high, and here also the accuracy is high, here also the accuracy is high. If you observe the confusion matrix, that also same. So that means every model is performing well for this data set. Now let's take the final one, that is vines. So we also have this vines data set. This also contain this is also the famous data set itself, and this input features will contain actually 13 chemical properties like alcohol or magnesium. Like the 13 chemical properties will be there. So based on that chemical properties, we will actually classify that into 3 categories of vines. So that also we are loading. Now let's test this model as well. I'm just rerunning this. Now we loaded vine related data and we testing our model. Now okay, navy bias model is working well. Okay, SVC model is also working well, as well as this random forest model is also working well. So I think based on the parameters and SVC, like based on the parameters that we provided, it is working very well. So sometimes it might not happen with your actual data set. So during that time, so which model is providing you the high accuracy, such model you need to prefer. In this way, we can able to select a model based on the accuracy as well as a confusion matrix in real time. So in real time, you need to load your data, then you need to observe which model is the best fit for you, and so you need to split your data set into multiple like testing as well as training data. Then after you need to pick the model. If you observe multiple models are suitable for your requirement, then you need to take those multiple models and train those models and predict the output, find the accuracy, and observe which is performing high or which is performing outstandingly compared to the models that you selected. So pick that one for your specific use case. So that's the great suggestion, or that's the best practice we need to follow while selecting a ML model in multiple models. So we have implemented this, that is how to select ML model based on accuracy of each and every ML model related to our training data set. I hope you understood this video and you got some knowledge insights from this video. So if you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye.